Let's remember on the polar area graphs that you have a formula from your BCX or video lectures. The area formula for a polar graphs is just 1/2 times the integral of r squared, where those numbers attached to the integral are your angles. And they even tell us what those angles are supposed to be. There'll be graphs we do with these in the future. We'll have to look at the picture and kind of get those angles by ourselves. But right now they tell us go in between 0 and pi. They tell us what the r is. So you throw it in there and you square it. And then math 9 that thing right there, you use your normal variable button when you're plugging this into the calculator, like your X button, but just math 9 that thing and round it to 3 numbers after the decimal. Now for part B, when it starts talking about X coordinate and Y coordinates on these polar graphs, where you have nothing but R's and thetas that you're given, you have to remember your pre-cal stuff that were reviewed from the video. So since they're talking about X coordinate, I'll go X equals R cosine theta. If they're talking about the Y coordinate, I'll go Y equals R sine of theta. But they tell me the X coordinate is -2. So I got to get an X involved. So I know that X is R cosine of theta. And they tell me that X phi is equal to -2. And then they tell us the R, that equation, and then the cosine carries down. And then you could rewatch the graphing calculator video if you want to review how to find the zeros of a graph. I got that in detail for you. At the beginning here, I'm going to work that out one more time with you, just so we have it. But anytime you have a difficult equation to solve and you're on the calculator part of the test, you don't have to solve that yourself. You're going to move everything to one side and then graph this thing right there. Set it equal to 0. Graph this thing right there. And we're going to let the calculator find those zeros for us. So when I entered it into the calculator, I already have that in here. And then notice I'm just using my X, my variable button. I'll scroll over in case you tried to graph it and it wasn't working out. You can see how I did on my parentheses and everything. But that's what that should look like. Now, on a normal graph, I'm talking zoom 6, but on a trig graph, I'm going to hit zoom, and then I'm going to hit number 7 always on a trig graph. And sometimes when that does that, it looks pretty chaotic. I'm not sure what I'm supposed to do. Notice that there's 2 spots where that thing is equal to 0. But remember, our problem here is in between 0 and pi. So which means I can hit my window button, and I can make my X min 0, and then go down, make my X max pi. And then when I hit the graph button, just the portion of the graph that I care about pops up on the actual screen. And there's only one spot where this thing is going to cross the x-axis. And I'm going to let the calculator find that number for me. And then we're going to be done with part B. So what we'll do, remember, we'll trace it. And we'll put our cursor over there in that vicinity. And then once you put that over there, you're going to hit second trace is always your calculate menu. So we're going to hit second trace. I'm trying to calculate a 0 here. So you either hit number 2 or go down to number 2 and hit enter. And then when it brings you back out to your screen, it says left bound question mark. You have to make sure it's to the left of that x-intercept right there. So if we just move it to the left a little bit, I'll hit enter. And then it says right bound question mark. You have to move it on the right side of that intercept. So on this function, since it's decreasing, I got to move it on the other side of that x-axis right there. So I'm just going to move it to the right. I'm going to pay attention to that y variable, make sure that switches sign on me. And once it goes in that negative area, you could just hit enter again. And see, it puts those arrows on to tell me that my intercept is in between those 2 arrow things. For a guess, you already narrowed it down. So for a guess, I'm just going to hit enter a 3rd time. I usually never guess. And then it gives me this 2.786 number, which is what I got right here. So in the future, I'm just going to refer to that graphing calculator video. If you forget how to do that, you can rewatch the graphing calculator video. That way I don't have to show that technique every single time right there. But it does the work for you. You just got to get down that x equals r cosine of theta part of it. Letter C just says the drd theta is negative. Remember, if your derivative is negative, that means that particular thing is decreasing, which means our radius is decreasing there. And so since our radius is decreasing, that particular curve is getting closer to the origin. We'll have a different concept with that. I believe the 2007 test, I have a handout and I'll explain to you this little technique that we'll use for stuff like that. But for now, just know, hey, that drd theta is negative. So that means your radius is decreasing. And then for letter D, it's talking about the greatest distance from the origin. Now, anytime you see something for finding the maximum value, minimum value, greatest amount, least amount over a closed interval like this, what they're meaning for us to use is this is your blue sheet that I'm going to refer to. This is a 3.1 absolute extrema problem where we're going to make an XY chart and we're going to need to check the endpoints of the interval in the critical numbers. Anytime you see greatest amount, least amount, maximum, minimum over a closed interval, we'll see this quite a bit. It would be A, B, and B, C. We're going to make a normal XY chart, check the endpoints and the critical numbers. So to obtain our critical numbers, remember, that's just where the derivative is equal to 0. So they gave us that derivative. I didn't even have to find it myself. Set that equal to 0 there. And then I'm just going to review some pre-calc here first. If you isolate that trig function, remember your cosine is positive. From your all students take calculus, your cosine is positive 1 and 4, which means your cosine is negative in 2 and 3. Your reference angle where your cosine is 1/2 is the pi over 3. So if you're going to give me a quadrant 2 answer, that's your 2 pi over 3. Quadrant 3 answer, that's your 4 pi over 3. And take whatever that weird angle is, set it equal to that, and then divide everything by 2, and we get a couple numbers there. I throw this one out because it says we're in between 0 and pi over 2. That's just in your first quadrant there, so I threw that one out. So this is our critical number, is the pi over 3. And I'm going to do my 3.1 absolute extrema process there. I'm going to make an XY chart. In this case, it's a theta R chart. And I'm going to throw in the endpoints of that interval, the 0 and the pi over 2, and also the critical number. And I guess this is on the calculator part of the test, so you could just take those thetas right there, plug them into your original function for the theta, and then I kind of did the exact values first because I was kind of practicing that without the calculator, but you could plug it into the calculator and just see which one is your highest one. Now, if they say what is the maximum radius, that would be the 1.913. If they say where does it occur at, this one specifically says find the value of theta where that maximum distance from the origin is, and that's what the R is. That's the distance from the origin. So once I maximize that R, it says find the theta. So that means my theta is the pi over 3 right there. Sliced peaches.